Hello and welcome back. Let's do some exercise to understand the turn on and turn off process with the proper VGS. So consider N-channel MOSFET IRF Z44N. So rating of MOSFET are VDS is 55, ID is 49. Here concentrate on VGS 20 volt maximum and threshold voltage is 2 to 4 volt. RDS on is 0.0175 ohm. So the goal is to understand turn on and turn off control. Let's take an example of low side circuit with this MOSFET. So in the circuit, just observe voltage source connected to the load of 10 ohm resistor and the N channel MOSFET and ground. This is the complete circuit. Here is the gate terminal. We are not bothering about any gate resistor or any other component yet, right? So just gate voltage source. So we need to predict the output of this voltmeter which is connected across the resistor. So that means when the switch is on, the current will flow through resistor and total voltage 24 volt will appear across the resistor. So we can know either switch is properly on or not, right? This is case 1. Only one switch is on. So there are two switches. One is connected in series with the source, we call it gate source or gate voltage, and one switch is connected which connect direct gate to the ground. So this switch is open right now and this switch is closed. That means 5 volt is applied to the gate terminal. So let's see, 5 volt is applied. Let's check the threshold value. Threshold voltage is 2 to 4 volt. That means it should turn on simply, right? So let's check the output. Yes, output will be 23.93 volts. 0.07 volt is the drop which is due to IR drop. Resistance we know that is 0.0175 multiplied by current flowing through. This will be the voltage drop ideally considered, right? So this is that means switch is on. Now let's consider the second case. Only switch 2 is closed and switch 1 is open. That means gate terminal is directly connected to the ground. So that means gate voltage is less than 2 volt and the voltage should appear in voltmeter is 0, right? So let's check out. Yes, so voltage is 0. That means switch is open, right? This MOSFET is not performing channel, and because gate is at 0, the MOSFET is open and output voltage is 0. So here everything is fine. Now consider the case 3. If both switches are open, what's happen if both switches are open? That means neither the 5 volt is applied to the gate, neither gate is connected to the ground. Then what will happen? So guess, any guess? Let's check it out. The output voltage, and in this simulation output voltage is 21.6 volt. So even without applying the gate voltage, it is the floating point, and at floating terminal some voltage may appear which may be greater than the threshold value. So it is partially on, right? So not 24 volt, but with the loss of voltage 21.6 volt appears across the load. So what we need to conclusion and what we need to understand from this case study is that need to ensure the proper turn off of the MOSFET, right? We need to ground it properly. So ensure VGS remains 0 to turn off the MOSFET and not floating. This is important point. Not that MOSFET will turn on at VGS only, 2 volt only, not at 20 volt. So understand that it is not only about turn on and turn off the MOSFET, but it is also about fully turn on and fully turn off, to understand what is fully turn on and what is fully turn off of the MOSFET. So ultimately we need better understanding of gate drive circuit and components, right?
Thank you for watching this video. You've just watched one complete lesson from the course, Mastering MOSFET and IGBT Gate Driver Circuit Design, a practical guide, created and taught by Dr. Jignesh Makwana, PhD, in Electric Drive and Power Electronics from IIT Roorkee, and available on Rhyni Tech, Skills and Fundamentals. If you found this lesson helpful, structured, and easy to understand, then this is just the beginning. The full course goes much deeper, covering practical gate driver design, real-world challenges, design calculations, protection techniques, layout considerations, and industry-relevant examples that are rarely explained clearly in textbooks or free videos. The course link is provided in the video description, and for a limited time, there is a special discount code valid only for the first week after this video is uploaded on YouTube. So if you're watching this early, don't miss the opportunity. This course is also available as part of the Rhyni Tech membership. That means with one membership, you get access to all electrical engineering and electric vehicle courses by Dr. Jignesh Makwana, along with hundreds of additional courses on online business, freelancing, productivity, and self-improvement, all under one platform. If you're serious about building strong fundamentals, upgrading your practical design skills, or preparing yourself for industry, research, or higher studies, you can also join the online School of Electrical Engineering, available with yearly or lifetime access. This gives you a complete structured learning path, from fundamentals to advanced topics, designed specifically for electrical engineers, power electronics engineers, EV professionals, and researchers. Take a moment to explore all the available options. Choose the option that best suits your learning goals and career plans. If you want to design with confidence, understand why circuits work, not just how, and learn directly from real academic and industry experience, then I'll see you inside the course. Thank you once again for watching, and happy learning.